Good evening, Dr. Baker. This is Ruben Pinkson yet again with the Multi-Factor project on Presentation 5. Project mentors on this haven't changed, as has the project statement. We're still trying to simulate the multi-factor effect that occurs in outer space by first learning more about it and the secondary electron yield, SEY curves, by implementing the newer already made curves using CST or an electromagnetic field simulation software, simulating the multi-factor effect of created curves in Spark 3D and analyzing the effects, and comparing simulation results with existing predictions. For last week's deliverables, I was able to actually discover and solve an annoying CST problem that was causing me to not make a lot of progress for at least 3 days in the week. I did simulations for 6, 10, and 20 gigahertz to find the lower and upper thresholds, and I was able to successfully import pre-made SEY curves into Spark 3D. So for the CST bug, it was mainly caused by the fact that if the dimensions were quote-unquote too small, CST is unable to export an electric field to Spark 3D. And by too small, it was simply like if the CST file had an input thing of meters and I put it in millimeters, just a simple conversion from meters to millimeters, millimeters to meters, then it would just perceive it to be too small, and when I tried to actually simulate the multi-factor effect in Spark 3D, it would not send an electric field, resulting in the electron sort of just sitting on the object, as seen in this picture, due to there being no electric field present. And from that, there would be no multi-factor, since the electrons aren't moving. The solution to this was simply enough setting CST to millimeters instead of meters, and that somehow solved the problem, so whoop-de-doo, it's not going to affect us anymore. For the 6, 10, and 20 gigahertz simulations and CST, I made a new vacuum block. What was that? Made a new vacuum block with the new dimensions of 2 millimeters, 2 millimeters, and 1.2 millimeters. 2 by 2 by 1.2. This is based off new frequencies and desired 2 millimeters dimension. I also added frequency monitors to 6, 10, and 20 gigahertz with power monitors to help verify Spark 3D results. On the bottom you can see the new vacuum block dimensions, and on the right you can see the new vacuum block with, of course, the frequency monitors. In Spark 3D, I tested the effects of varying electron populations and looked for lower and upper multi-factor thresholds. The results, varying electron populations still had a minimal impact on results. I tested between 700 and 5,000 for a population, and they really didn't cause humongous changes around it. The biggest ones occurred for 20 gigahertz, but overall it was showing really similar results to last time. Also, increased runtime did occur for around 2 to 3 hours, though I will note that this could be 18 plus if electron population was, that's a typo, but above 5,000, not 500, since I did have one simulation that just went way too long when I tried to set it to, I think, 7K. But from this, I was able to find the thresholds. For 6 gigahertz, I found the lower threshold being about 885, 0.32, when averaging all the results. And for the upper threshold, I was able to find 6504.96 in watts. Both of them are in watts. Then for 10 and 20 gigahertz, I was able to find anything that I could identify as an upper threshold. I'll be meeting, of course, on this week to see what can be done on that, since I did mess with things such as setting the power on these to higher levels in order to find a higher threshold, which was found for 6 gigahertz, but not for these two. And these ones, I'll just label it as an upper threshold right now, but 10 gigahertz had about 2450 watts, and 20 gigahertz had around 9847 watts. And examples of these simulations is right here with this little graph, of course, showing the multi-factor results, and the left one showing the lower threshold of multi-factor for 6 gigahertz, and the right showing the upper threshold of multi-factor for 6 gigahertz. As you see, for the 10 and 20, they don't really they don't really vary. They're still in the same ballpark, so I don't know if it's either a really high and low threshold. If there's not a lot of distance between the high or low threshold, or if there simply isn't something I haven't done yet. For input SEY curves into Spark 3D, Luca gave me some custom SEY curves he had made, simply ones that showed the EV energy and the SEY values, EV being impact energy. And when formatted in the correct way, I was able to import these custom SEY curves into Spark 3D. I did so by converting his little notepad-like texts into Excel and making them into CSV files, according, of course, to the Spark 3D user manual, which wanted each column to show first a column of all the SEY values, and then another column right after that with all the impact values. This notably only worked when all the words were removed from the file, so I couldn't have any titles on them. And here's a little graph with the SEY curve showcasing it for the file that he called SEY1C_59. I'm going to follow up on what exactly that means for the curve, but this is what I was able to generate with the graphic in Spark 3D, showcasing the actual SEY curve. And for the confirmation it actually works, I was able to simulate it with the 6, 10, and 20 gigahertz, showing no breakdown for 10 and 20, and one about 2340 watts for 6 gigahertz. For next week's deliverables, I'm going to continue doing research on electron drifts. I was sort of lacking on that this week due to the fact of I had to deal with that bug until Wednesday, and then the rest of the week was dedicated to getting data. I'll work, of course, on more CST and Spark 3D simulations, most likely involving different frequencies, and hopefully, and most likely, I'll actually be able to start simulations with the custom SEY curves using Spark 3D, which will help us get into the latter steps of our project by comparing them with the predictions that Luke had. For the budget, it hasn't changed when it comes to materials, and for the overall budget, I simply added a lot more hours this week, going from the one I had before to 88. I also gave Luke some hours as well, since me and him did both try and solve the issue of the CST bug earlier this week to no avail, even if it was solved eventually, putting us still below budget, though we're rapidly going on, so we may have to increase that total estimate in the future. Gantt chart shows nice progress going so far, with, of course, CST going very nicely. I need to modify the SEY curves part because that belongs for Spark 3D, but we've actually started simulating those. For Spark 3D, we're full on route for doing not only the research, but designing the simulations and, of course, getting the data. And for predictions, I've been able to make an Excel sheet showing analysis of these predictions and simulations, so we're going pretty nicely on track so far for week 4, and we're most likely going to complete this project by the end. I would say any questions, but this is just a video, and that is all I have for this week. Thank you.